Alright, so today we will be
explaining on Pascal principle,
And the ones who will be presenting are
Cause my job got me going nowhere, so I ain't got a thing to lose. Take me to a place where I don't care. This is me and my liquor store blues. I'll take one shot for my pain, one drag for my sorrow. Get messed up today, I'll be okay tomorrow. One shot for my pain, one drag for my sorrow. Get messed up today, I'll be okay tomorrow. Me and my guitar tonight, singing to the city lights, trying to live with more than what I got. 68 cent just ain't gon' pay the rent, so I'll be out until they call the cops. Cause my job got me going nowhere, so I ain't got a thing to lose. Take me to a place where I don't care. This is me and my liquor store blues.
Hello. Assalamualaikum. So my name is Muhammad Faris Faik, and my part today I will be explaining about the definition of Pascal principle. Do you guys know what is Pascal principle? Basically Pascal principle is generated from a law which is called Pascal law. The definition of this principle is a pressure change in one part is transmitted to another part without any loss of energy to the fluid and also to the wall of the container. Alright, this principle was discovered by one handsome genius Frenchman which is called Blaise Pascal. Blaise Pascal has concluded this Pascal principle with one simple formula, which is pressure is equals to force per unit area. And according to Pascal principle, in an hydraulic system, a pressure exerted on a piston produce an equal increase in pressure on another piston in the same system. Like for example, if the second piston has an area of 10 times larger than the first piston, which means the force on the second piston is also 10 times greater than the force on the first piston, which is 10 times smaller. This effect is also called as hydraulic press, and one of the application that use this kind of principle is hydraulic brakes. Other than that, Blaise Pascal also found that pressure at a point in a fluid at rest is the same in all directions. The pressure would be the same on all planes passing through one specific point. All this fact that I have told is actually known as Pascal principle. So that's all from me. If you want to know more about the application and also the troubleshoot that might happen when using this Pascal principle, my friend will be explaining about that. So let's see.
Hi, I'm Stacy Bajajamon, and as for my part, I will explain on how the principle is applied in the brake system of a vehicle. So, do you guys have any idea on how this principle work? No. So, do you guys know how does it multiply the force so that it is enough to stop something as big as a car? No, right? Okay. So for now, I will explain to you how it works. Since Pascal law states that the pressure at any point in a static fluid is the same in all directions, this tells us that any additional pressure will be transmitted equally throughout the fluid system and through the brake line. As we can see that The brake system has two kinds of cylinders, which is the master cylinder near the brake pedal and the wheel cylinder in the wheel mechanism. When we applied a force F1 into the master cylinder with the area A1, the pressure P1 will be created with the formula P1 equal to F1 over A1. The pressure is then transmitted equally into the wheel cylinder and to the wheel piston to create a pressure P2 with the formula P2 equal to F2 over A2. Since P1 equal to P2, thus the pressure exerted out on the wheel piston F2 will increase by the ratio of A2 over A1. Thus, the force F2 created with the formula F2 equal to A2 over A1 times F1. So, this is all from me. This is how the Pascal principle is applied in the brake system of a car. Thank you.
Hi, I'm Nolena Mutimanlan and I will explaining about hydraulic brakes, the application. So, we all know cars will slow down and stop when we apply brakes. But how does this happen? And how does force exerted on a foot pedal and stops or slows down a car? So this is a cross-section area of the automobile hydraulic brakes. As we can see here, there is a pipeline containing fluid, and the end of the pipeline is connected with the master piston fitted with the paddle third. And the other end of the pipeline is connected with the wheel cylinder, which contains two types of piston. It is actually the same piston, but there's two pistons. And there's piston 1 and piston 2, as shown as the diagram clearly shown in the figure. The cross-sectional area of the master piston is smaller compared to the cross-sectional area of the wheel piston, the four-wheel piston. Okay, let's see what happens when brakes is applied. Got it? To make it more clear, I will show you a cross-sectional area of a wheel when the brake is applied. Before that, this is the picture of a wheel, of a common wheel. And this is the cross-sectional area of the wheel. When the brakes is applied, the foot pedal will push due to the force exerted on the fluid on the master cylinder. This pressure will transmitted equally throughout the fluid. Therefore, the piston get pushed outward like this. Ta-da! Ding. When releasing the pressure on the pedal, the return spring forces the piston of the wheel cylinder back, and the fluid flows back into the master cylinder. So that's all the application of the hydraulic brakes. Thank you.
Hi, I am Nur Zarifah Suraya, and today I'm going to explain to you about how to solve a problem arise within the hydraulic brake system, which is a system that is sensitive to moisture and corrosion. Usually, drivers nowadays will only inspect their car brakes when there is a problem. Hence why rotors, pads and other components are kept beyond their proper and safe use by dates. Here are some common problems. First, no brake fluid, which usually means a leakage in the brake system. If you're experiencing a soft brake pedal, have a service technician look for fluid leakage from the master cylinder or elsewhere in the brake system. The master cylinder is the unit that creates the power for your brakes. It has reservoir like the one for your wiper fluid that contain brake fluid. When you apply the brakes, this fluid is pushed through thin piping, creating hydraulic pressure. If fluid is leaking from this system, there may not be enough power to force the brake pads to clamp hard to the rotors. Like this. The vehicle should not be driven until repairs are made to this system because a leak may cause brake failure. The second one is the metallic squeal while you're in motion. Have you ever heard a high-pitched sound that stops when you apply the brake? That is likely the sound of the brake pad wear indicator. They are made out of steel and they make this high-pitched sound when they start contacting with the rotor, which means that they are letting you know that your brake pad is worn out and need to be replaced immediately, or else there will be a rotor damage which will cost you an expensive repair, which is the need to replace the drum and rotor, and in addition to new linings and brake hardware. Problem number 3, soft brake pedal. If you notice a difference in the resistance of the brake pedal, which the brake pedal feels softer, or it sinks all the way to the floor mats when you press into it, it's a sign you need immediate service. There could be air or moisture in the braking system or a problem in the master cylinder. Generally, in autos with power brakes, the pedal should stop 1 or 1.5 inch from the floor. Regular inspection provides greater safety for motorists, greater replacement rate for workshops, and the opportunity for you to upgrade to higher quality components and less accident risk. And that is all for today. Thank you.
So,